hello, this is project 3. We're gonna make this really fast. And so if you look up, this is at 0.917 millivolts. And if you look down, this is also at about 0.93. We're close to spec. It's about 20 millivolts off. That's okay. Now, if we move up very slowly, we're gonna move up. You're gonna see this change in real time. You can see that bar graph move up. We're about 1.42 volts now, because that's how the oscilloscope changes, kind of annoying. And then we're gonna move up slowly. You're gonna see that increase to about 1.8. And now we're just gonna move all the way up to 2.5 volts. And see, we're at 2.5 volts, because that's the max that the function generator can open. And so now we're gonna be doing a 3 volt peak to peak sine wave. And we're gonna be looking at 500 hertz at an offset of, 1.5 volts and an amplitude of 3 volts. That was too big, far too big. That might have actually destroyed our board, but that's okay, we'll see. And if you look, you'll see those DC RMS values and whatnot. And we'll see a frequency of 500 hertz, voltage peak to peak, and pretty accurate voltage readings. Now we're gonna bring our frequency up to 1,000 hertz. And we're gonna bring our offset down to, we're gonna bring our amplitude actually down to a volt. And we're gonna bring our offset down to half a volt. We're gonna get there eventually. And now if you look at the measurements, you'll see frequency readings within spec and fairly close voltage measurements. And here we're gonna move on to the 1 volt peak to peak sine wave at 2.5 volts DC offset. And so you can see here, values, and that's 2.5 volts. And we see, again, within spec. And now we're gonna be moving on to a 3 volt peak to peak triangle wave with a 1.5 volt DC offset at 50 hertz. And so we're gonna make this a triangle wave, and frequency is gonna go, let's change our 1.5 volt DC offset first, and make this a 3 volt peak to peak. 3 volt peak to peak, and we'll see that sweet triangle wave. Take a quick close gander.
The frequency, right?
Yeah, we're at 50 hertz. Let me change this down. I got ahead of myself there. Right, we're at 50 hertz, nice and pretty. If we take a look, we're at 49 hertz, 3 volts peak to peak, and a different RMS, as well as a different DC voltage. And here we're gonna be taking a detour to the frequency specifics first, and we're gonna be going to the 3 volt peak to peak sine wave. And this is gonna be running at a frequency of 1,000 kilohertz. And that's 1,500.
1 kilohertz.
Yeah.
1,000 hertz.
This is the 1,000 hertz. And if we look down, we'll see that our frequency matches. And here's our problem. As we go down to lower frequencies below 25, it takes a very long time to update. And so we will demonstrate that with going down to about 50 hertz first. And you'll see me slowly decrease it until it starts not working very well. Even at 50 hertz, you see that it's a little slow to change to responses. So we're gonna change this down to 44, change this down to 40. And so I'm at 40 right now, and it's gonna take a while for it to change down to close to 40. And if I change it to about 29, changed fairly close. Now I'm down at 20 hertz. It's gonna take a while to change, and if you go too low, it breaks the code. So unfortunately, we cannot demo frequency of 20 hertz and below, it seems. But other than that, that is our project 3. I hope you guys are happy.